Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 1, Chapter 1, Index Numbers, brought to you by Vitan, Sir. Previously, in this tutorial, we studied about the Laspeyres, Pasches, and Fisher's index number, along with the weighted average index numbers, that is certain specific formulas which we studied in the previous tutorial. Now in this tutorial I am going to start with exercise 1.3, which contains the practical sums based on the formulas which we studied. Let's start. Question number 1. The information about 6 different items used in the production of an electronic item is as follows. We have to find the index number and interpret. Okay, so we have to calculate the index number and then interpret it. The data given is like this. We have the items A, B, C, D, E, F. We have the weights already given 5, 10, 10, 30, 20, 25, and the percentage price relatives are what we have here. Now let me remind you once again, then the percentage price relatives themselves mean index number. You can refer to my first tutorial for this. So the percentage price relative are 290, 315, 280, 300, 315 and 320. What we need according to our equation is we need summation IW divided by summation W. So the weight here is W, and W and index number, that is weight and index numbers, are directly given. So we need to start with IW, that is multiplying weight with the index number, that is the percentage price relative. So multiplying these values will get us these answers here like this. Once we have all these answers, we need to make a total of these two things, the weights and the index number with weights. So the total of weight is 100. The total of IW is 30,700. So next I'm going to apply the formula of general index number, that is summation IW upon summation W, and the answer here will be 30,700 divided by 100, that is 307. So we also write a statement. The rise in the prices of 6 items used for an electronic item is 307 minus 100, that is 207% in the current year compared to the base year. So this is how we write a statement at the end of each index number. We subtract 100 from the index number to show the rise in the percentages of the current year values of the items compared to their previous year values. Let's move on to question number 2. The question number 2 is a similar kind of a question. The information about 6 different items used in a furniture is as follows. Find the index number for the year 2015 with base year 2014 and interpret it. The data given is items, weight, prices of 2014 and 2015, A, B, C, D, E, F. Now in the previous question, weight and index number was directly given, but in this question, weight is there, index number is not there. But what we can do here is that we can calculate index number using the values of the prices of 2014 and 2015. We have to take the current year as 2015 and base year as 2014. So we can calculate index number as price of current year divided by price of base year into 100. So similarly, we can calculate index number for all of these values. So 24 upon 30 into 100, 80. 24 upon 20 into 100, 70 upon 50 into 100, 40 upon 32 into 100, 48 upon 40 into 100, and 24 upon 16 into 100. We got all the index numbers. Next I'm going to multiply the weight with the index number here. So 17 into 80, so 18 into 17, 1360, 120 into 15, 1800, 140 into 22, 3080, 125 into 16, 2000, 120 into 12, 1440, and 150 into 18, 2700. Now we need to make a total of the weights of these values, the total of weight and the total of IW. These are the only two totals which we need. The total weight is 100 and the total of IW is 12380. Next, we calculate the general index number for I, that is summation IW upon summation W, that is 12380 upon 100, 123.80. And the statement here, the rise in the prices of 6 items used for furniture is 123.80 minus 100, 23.80% in the year 2015 compared to the base year 2014. So that's the answer. In question number 3, we have the years 2015 with the base year 2014. The data is given and we have to use that data to calculate the Laspeyre, Pasche and Fisher's index numbers. Now this is the data given in the question. We have the items wheat, rice, pulses, oil, cloth and kerosene. Wheat in the kg, rice in the kg, pulses in the kg, oil in the kg, cloth in the meter and kerosene in the liter. All are pretty simple units. We can basically just ignore this unit for now. Then we have 2014 and 2015. So 2015 is the current year, 2014 is the base year. What we have here is quantity and price for each year. We know that for Laspeyre and Pasche's index number, we need the current year and base year pricing quantities both according to our formulas. Okay, I have told you guys the 1000 and the 1101 system of calculating how Laspeyre and Pasche can be calculated, and the Fisher is just the geometric mean of these two index numbers. But what we need to understand here is that this 2014 is the base year, so the base year quantity is Q0, the base year price is P0, the current year quantity, the 2014 15 quantity is Q1 and the 2015 price is P1. So this is Q0, P0, Q1, P1, and based on that I'm going to draw another table where I'm going to start with 1000. So PQ with 1000 as its suffix. That means this will be used for Laspeyre, P1Q0, P0Q0. So that means that if I want to calculate P1Q0, I am going to multiply P1 with Q0. Next, if I want to calculate P0Q0, I am going to multiply P0 with Q0. So all these values will be multiplied and written here. Next, I have to use the suffix 1101. You can see here 1101 here, that is for Pasche. So P1 Q1 means I will be multiplying the current year prices with the current year quantities, and P0 Q1 means I will be multiplied by multiplying base year prices with the current year quantities. Okay, so we have to start with the first one, P1 Q0, that is multiplying this 18 with 20, you get 360. Similarly, multiply this whole column with this whole column and you get these answers. Don't make a mistake while multiplying these values, else you will face the wrong answers and it is very difficult to write them after we have got the wrong answers. P0 Q0, that is multiplying these two values, these two values here. Okay, all these two values will be multiplied with each other and that way you can get these answers. Next, P1 Q1, multiplying these two answers, these two values. Okay, similarly we are getting the values here with multiplication, and then the last one, P0 Q1, that is P0 and Q1. So these two values, you can see here that all the possible combinations are being done between these four things. Okay, price with quantity, that's the main motto here. First should be the price, next should be the quantity. That's how we do things. So we have got all these four columns for this two for Laspeyre and these two for Pasche. We will just make a vertical total for these values. The totals are written in the red here. These are the total values of all these four columns. Now we start with our Laspeyre's index number, that is summation P1Q0 upon P0Q0 into 100. So this P1Q0 total is 2040.9 and P0 Q0 is 1610.55 into 100, and when you solve this you get 126.72. Next we have the Pasche P1 Q1, so and divide by P0 Q1. So we just take this 3180.25 value divide by 2507.15 into 100, and when you solve this you get 126.85. Last we have to calculate the Fisher's index number. It's simple, it is just the geometric mean of these two answers. So you just need to write down these two answers in the equation here, multiply them and root them, you will get your answer 126.78. So this is a simple Laspeyre's, Pasche and Fisher's index number method where you denote the appropriate symbols to these values so that it becomes easy when we are creating 4 columns. Whenever you are calculating Laspeyre, Pasche and Fisher, you will need to prepare these 4 columns, because without these 4 columns you can't get your answers. This is an important concept in this IL, IP and IF system, so bear that in mind. Question number 4. Now again we have to find the Laspeyre's, Pasche's and Fisher's index numbers for the year 2015 with the base year 2014. This time we have a bit of a different data here. See, the items A, B, C, D are given, the units are there, but as you can see, compared to the previous question, the units in this question are a bit different. We have for the item at 20 kg as a unit. That means if I have the prices of 2014 as 80 rupees, then this 80 rupees is for 20 kg. Okay, while the consumption is given in just 5 kg. So when I will be calculating data for 5 kg, I can't multiply it with the price of 20 kg. I have to convert this price into a single kg price so that I can accurately calculate what is my total expense for this 5 kg unit. So that means I need to convert this 20 kg into 1 kg. Okay, just imagine you have the price of 20 kg is 80 rupees and you are multiplying it with 5. Basically you are not calculating for 5 kg, you are calculating for 100 kg. So there will be a mathematical error there. Therefore what we need to do is just first analyze this question. The unit here is 20 kg, so prices are for 20 kg while the given data is for 5 kg and 7 kg. So naturally I have to convert this 20 kg into a single kg value. So if price 80 and 120 are for 20 kg, then what will be the price for 1 kg? Accordingly I will calculate the price. For item B, I have the kg here. So 20 rupees per kg, 24 rupees per kg, but you can see the consumption is in grams. Now the common sense says here that rather than converting this kg into the gram prices, I should convert these grams into kilograms. 2400 grams clearly means 2.4 kilograms and 4000 grams clearly means 4 kilograms. So it is better to convert the consumption rather than convert the prices. So many times we have to use our common sense here. For example, quintal means 100 kg. So I have the quintal here, so 2000 rupees per 100 kg, that is per quintal, 2800 per quintal, but my consumption is in simple kilograms. So naturally now rather than converting kilograms into quintals, I should convert quintals and prices into kilograms. That is easier than converting these things into quintals. Similarly, dozens are 12 pieces. Okay, so 30 pieces and 35 pieces are my consumption here, and the price is for dozen, 48 rupees per dozen, 72 rupees per dozen. So what I'm going to do is I'm going to convert this dozen and the prices into per piece price. For that purpose we have to recreate the whole table here. Items will be there in the prices for base year P0, for current year P1, consumption for base year Q0, for current year Q1. The units I have pre-converted here. So 20 kg is kg, kg is kg, quintal is kg and dozen is pieces. Now this 20 kg is to be converted into single kg, so this 80 will be divided with 20, so I will get 4 rupees per kg. 120 will be divided by 26 rupees per kg and quantity will be as it is. Next, kg, the price I am not going to convert here because the unit has not been converted. but this consumption is converted. So 2400 grams divided by 1000 grams, that is 2.4 kg. 4000 grams divided by 1000 grams, that is 4 kg. So I am converting this consumption according to kg. What we need to remember is this unit sign and this should be same. First thing, this should not be 20 kg, this should be 1 kg, and kg should match. For example, if this is gram here and kg here, I will convert gram into kg. If there is kg here and quintal here, I can either convert quintal into kg or convert kg into quintals. If there is a pieces here and dozen here, I can either convert dozen into pieces or convert pieces into dozen. So this should match, this and this should match. Next, I am dividing quintal with 100 to get a kg. So this price will also be divided by 100. So 20 rupees per kg and 28 rupees per kg. Of course, the consumption is not going to change here. Next, pieces. So I am converting dozen into pieces. Dozen means 12 pieces. So I will be dividing my prices with the value of 12. So 4 rupees per piece and 6 rupees per piece. That's what I'm going to get here. And the consumption is going to be the same. So now this is the new table. These are the new values which I'm going to use in my calculation, and thus I'm going to prepare my regular table of Laspeyre 1000 P1Q0 P0Q0 and Pasche 1101, that is P1Q1 and P0Q1. So P1Q0, now here already titles are there. P1 is multiplied with Q0. Okay, so this 6 will be multiplied with 5. So new values wherever available we have to use for the calculation. So 6 5s are 30 and 24 into 2.4 and 28 into 10 and 6 into 30. Next, P0 Q0 is multiplication of P0 with Q0. Okay, this value with this value is what we are going to multiply here. 4 5s are 20, 20 into 2.4, 20 into 10, 4 into 30. Okay, you are getting the answers. P1 Q1, so that is P1 and this is Q1. So that's what we are going to multiply here. 6 7s are 42, 24 4s are 96, 28 15s are 420 and 6 35s are 210. And P0 Q1, this is P0, this is Q1. So we multiply this. 7 4s are 28, 4 2s are 80, 4 2s are 8 and 0 80. 15 20s are 300 and 35 4s are 140. Just to make a total of all these 4 columns here, you get them in red. As no more spaces left in this slide, I am going to continue onwards in the next slide for calculating Laspeyre, Pasche and Fisher's index numbers. Index number of Laspeyre P1Q0 upon summation P0Q0 into 100. From the previous slide, we know the value is 547.6 upon 388 into 100. Then 141.13 divided by, that's the answer actually, and we can say that there is a rise by 41.13%, that is 141.13 minus 100. Next, index number of Pasche, that is summation P1Q1 upon summation P0Q1 into 100. Just put the value 768 upon 548 into 100 and then 140.15. So rise of 40.15%, that is 140.15 minus 100. Next, index number of Fisher, that is the geometric mean of Laspeyre and Pasche's index number. So 141.13 into 140.15, the multiplication and the root, that is 140.64. So rise of 40.64%, that is 140.64 minus 100. So my dear students, sometimes this kind of questions are asked where you have to convert the given values according to the units provided and the consumption units of measurement, etc. Create a new table and then use that table to create Laspeyre, Pasche and Fisher's index number. Let's take one more question for that purpose. Question number 5. Find the ideal index number from the following data for the year 2015. Now the question is about calculating ideal index number. As I have explained in my previous tutorial, that ideal index number is Fisher's index number. That means you just need to calculate Fisher's index number. You don't need Laspeyre or Pasche's. But to calculate Fisher's index number, we need the data of Laspeyre and Pasche's index number. So we will do the same amount of work which we have done previously. The items are A, B, C, D. The units are 20 kg, 5 dozen, kg and 5 liter. As you can see here, we need a lot of conversions. First of all, this 20 kg must be converted into a single kg value because these kgs are there, and for this purpose price should be divided by 20. This 5 dozen I believe should be converted into a single dozen. So this 120 and 140 should be divided by 5. I will keep these 3 dozen as it is, but this 48 pieces must be converted into dozen. So 48 pieces divided by 12 make it 4 dozen. Kg I am going to leave it as it is. This 5000 grams will be converted into kg. 5 liter I am going to convert it into a single liter. So price will be divided by 5. Yes, that's all. Let's do it. The rough shape is kg, dozen, kg and liter. P0, Q0, P1, Q1. As you can see, 2014 is base year, so price quantity P0, Q0. 2015 is current year, price quantity is P1, Q1. So I'm going to convert this 120 into 6 divided by 26, and 10 kg will be as it is. 280 divided by 20 is 14, and 15 kg will be as it is. Next, 5 dozen is converted into a single dozen, so 120 divided by 5, 3 dozen as it is. 140 divided by 5 is 28, and 48 pieces are converted into 4 dozen. Next, kg, so value is as it is, but 5000 grams is converted into 5 kg, and the remaining data will be as it is. This liter, 5 liter will be converted into single liter, so 52 divided by 5 is 10.4. 15 liters, then 58 divided by 5 is 11.6, and then 20 liters. I'm going to write down our regular table here. 1000 suffix, that is P1 Q0 P0 Q0, and 1101, that is P1 Q1 P0 Q1. Now let's start here with the multiplication of P1 Q0. This is P1, this is Q0. So just multiplying these two values here, as you can see, nothing new, just multiplication, simple. P0 Q0, that is, I think these two values must be multiplied. So 10 6 are 60, and 72 and 20 and 156, simple as it is. P1 Q1 is these two values which I will be multiplying here. So multiply these values with each other. These new values we will be multiplying, so don't make a mistake in multiplication, else you will not get your answer. And P0 with Q1 I'm going to multiply, so similarly I get the answers according to the question, and I make a total. So we are making the total of all the 4 columns here, and once we get this totals here, okay, the half work is done. Now we have to calculate Fisher's index number, that I am going to do in the next slide. So Fisher's index number is considered an ideal index number, and because we don't need IL and IP, we are going to directly use this formula for calculating Fisher's index number. Okay, this is the direct formula, that is P1 Q0 upon P0 Q0 multiplied by P1 Q1 upon P0 Q1 into 100. So just put the values of those columns here, then divide these values into 100 is out of the square root, so don't make a mistake. Multiply these values, get the square roots, and then multiply with 100, you get 142.57. So your statement will be rise by 42.57%, that is 142.57 minus 100. Okay, simple, right? Okay, now this is the last question for the exercise 1.3. We have to find Pasche's and Fisher's index number for the year 2015 with the base year 2014 using the data given below. Doesn't matter because we have to calculate Fisher, ultimately we have to calculate the whole data. This time it's a bit different. We have the items A, B, C, D, E. We don't have units, rather we have something new. In the 2014 we have the price and the total expenditure. Similarly in the 2015 we also have price and the total expenditure. Now price is something you are familiar with. This is going to be the base year price P0 and current year price P1. Where is quantity? The total expenditure which we have here is basically the multiplication of the price and quantity. You just imagine here, that you go to a shop and you buy 5 chocolates of 1 rupee each. So what's your total expenditure? 1 rupee into 5, 5 rupees. Similarly, the total expenditure is multiplication of price and quantity. That means the P0 Q0 is the total expenditure of the base year, and P1 Q1 is the total expenditure of the current year. I think you guys must get what I am trying to say here, that total expenditure is the multiplication of price and the quantity of the base year for 2014, and for 2015 the total expenditure is the multiplication of price and the quantity of the current year. So we don't have quantity, but if we want to calculate quantity, we can divide this total expenditure with price and we get the quantity of base year. Similarly, if we divide this total expenditure with this price, we get the quantity of the current year. Let's draw another table. Items A, B, C, D, E. This time I have written the symbols for basic understanding. Price of the base year is P0, Q0 which we don't have, and then total expenditure of the base year is multiplication of P0 and Q0. So when I divide P0 Q0 with P0, the remaining value is Q0. Similarly, for the current year, I have the P1, Q1 is something which I don't have, and total expenditure is P1 into Q1. This is how it is done. So now let's start with the calculation of the base year quantity. That is 400 divided by 100, 4. 500 divided by 100, 5. 600 divided by 150, 4. 1080 divided by 180, that is 6. And 1000 divided by 250, that is 4. Next, current year quantity. 720 divided by 120, that is 6. 600 divided by 120, that is 5. 800 divided by 160, that is 5. 1000 divided by 200, that is 5. And 1200 divided by 300, that is 4. Okay, now whenever we are calculating Laspeyre, Pasche, Fisher, we need the 4 columns. Okay, that is P1 Q0, P0 Q0, P1 Q1, P0 Q1. Now out of these 4 columns, we don't have P1 Q0, we have P0 Q0, we already have P1 Q1, but we don't have P0 Q1. So 2 columns have already been given in the question itself. Additional 2 columns we need to create. So P1 Q0, this is P1 and this is Q0. So just multiply these 2 values here. Okay, P1 and Q0. So 120 into 4, then 120 into 5, then 160 into 4, then 200 into 6, and 300 into 4. Next, P0 Q1, that is P0 with Q1, 100 into 6, then 100 into 5, then 150 into 5, then 180 into 5, then 250 into 4. Now just make the vertical totals of all these 4 columns: P0 Q0, P1 Q1, P1 Q0, and P0 Q1. So my dear students, now we have got our basic 4 totals and we can continue with our Pasche's index number. Index number of Pasche, that is P1 Q1 upon P0 Q1 into 100. I think we already have values for that. That is 4320 upon 3750 into 100. So 115.2. So the rise by 15.2%, that is 115.2 minus 100. Next, index number of Fisher. As we don't have Laspeyre's index number, we are going to calculate the whole Fisher's index number. Under root P1 Q0 upon P0 Q0 into P1 Q1 upon P0 Q0 out of the square root into 100. Just put the values which we have calculated in the earlier slide, divide these values under root and then multiply them under root, then make a root and into 100. You get 115.14. So rise by 15.14%, that is 115.14 minus 100. So my dear students, this is how you calculate an index number for Laspeyre, Pasche, Fisher, and weighted average index numbers. We have seen different methods for that: the weighted average index number method, then simple Laspeyre, Pasche method, then unit Laspeyre, Pasche, and Fisher methods, and then the total expenditure of Laspeyre, Pasche, and Fisher methods. Thank you very much for watching this tutorial. Next time we will move forward with the last topic of this chapter. Wait for that. Thank you very much. Welcome students to Vitan Sir's Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics, and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.